Welcome to Cosmic Chronicles, your journey through the universe. You need to hear this if you're a space enthusiast. If we don't act, the impact will be global within the next 10 years. Our planet is blanketed by an invisible danger: satellite air pollution. This is the reality of our increasingly crowded orbital space. For decades, we have launched satellites into orbit. These technological marvels have enhanced communication, navigation, and our understanding of Earth. But there's a hidden cost. Every satellite eventually falls back to Earth. As they re-enter the atmosphere, they burn up. This releases harmful chemicals into the air we breathe. This problem is growing exponentially. Private companies are launching mega constellations of satellites. These constellations consist of thousands of individual units. Their purpose is to provide global internet coverage. But the unintended consequence is a dramatic increase in space debris and subsequently, air pollution. We must acknowledge the problem, understand its implications, and find solutions. The future of our planet depends on it. The dawn of the space age brought incredible advancements. We launched satellites for communication, navigation, and scientific exploration. But the recent rise of mega constellations is unprecedented. Companies like SpaceX and OneWeb are launching thousands of satellites. Their goal is to create interconnected networks in low Earth orbit. This will provide global internet access. The sheer scale of these projects is staggering. SpaceX alone plans to launch tens of thousands of Starlink satellites. This exponential increase in satellites poses a significant environmental threat. Every satellite has a limited lifespan. When they malfunction or become obsolete, they descend through the atmosphere. The intense heat of re-entry causes them to burn up, releasing pollutants. We are essentially bombarding our atmosphere with debris. We must recognize this emerging threat and take steps to mitigate its impact. Earth is constantly bombarded by space debris. Most of this debris burns up harmlessly in the atmosphere. This natural phenomenon is responsible for meteor showers. However, satellite re-entry is different. While meteoroids are primarily composed of rock and ice, satellites contain a variety of manufactured materials. These materials, such as aluminum, beryllium, and plastics, can pose a threat to the environment when burned. Unlike the random distribution of meteoroids, satellite debris is concentrated along orbital paths. This targeted re-entry increases the risk of localized pollution. The rate of satellite re-entry is also a concern. While meteoroid influx is relatively constant, the number of satellites deorbiting is increasing. This is directly linked to the growing number of satellites being launched, particularly in mega constellations. As more mega constellations are deployed, the balance is shifting. The dangers of satellite air pollution are not immediately visible. They are not fiery explosions or catastrophic crashes. Instead, they are insidious. They work their way into our atmosphere, slowly but surely. The culprit? The very materials that make satellites so durable: metals and composite materials. Aluminum, a key component in satellite construction, is a prime example. When aluminum burns up during atmospheric re-entry, it forms aluminum oxide. Aluminum oxide is a fine particulate matter. These particles can remain suspended in the atmosphere for long periods. The presence of these particles in the air we breathe has serious health implications. Beyond aluminum, satellites contain a cocktail of other potentially harmful substances. The uncontrolled release of these substances into the atmosphere is a cause for concern. The environmental ramifications of satellite air pollution are far-reaching. The release of pollutants from burning satellites has the potential to disrupt delicate atmospheric processes. One of the most significant concerns is the impact on the ozone layer. The ozone layer, located in the stratosphere, acts as a shield. It protects us from harmful ultraviolet or UV radiation from the sun. Certain chemicals released during satellite re-entry, such as chlorine and bromine, can deplete this protective layer. Ozone depletion can have severe consequences for human health and the environment. Increased UV radiation can lead to skin cancer, cataracts, and immune system suppression. It can also harm marine ecosystems and disrupt plant growth. While the Montreal Protocol successfully phased out ozone-depleting substances in refrigerators and aerosols, the unregulated release from satellites poses a new threat. Climate change is another major concern. The particles released during satellite re-entry can influence the Earth's radiative balance. Uncontrolled satellite re-entry has the potential to exacerbate climate change. The Montreal Protocol stands as a testament to international cooperation. This landmark treaty, signed in 1987, successfully addressed the issue of ozone-depleting substances. It serves as a blueprint for tackling the emerging challenge of satellite air pollution. The Montreal Protocol phased out the production and consumption of chemicals that damage the ozone layer. The treaty's success demonstrates the power of collective action in addressing global environmental threats. We can draw valuable lessons from the Montreal Protocol and apply them to the issue of satellite pollution. First, it highlights the importance of scientific consensus in driving policy change. Second, the Montreal Protocol demonstrates the effectiveness of regulation. By phasing out the production of ozone-depleting substances, the treaty successfully reversed the trend of ozone depletion. Similarly, regulations on satellite design, launch practices, and end-of-life procedures could mitigate the environmental impact of space debris. We need to invest in technologies that minimize the environmental footprint of satellites, both in orbit and during re-entry. International space law, as it stands, is ill-equipped to deal with the growing problem of satellite air pollution. Existing treaties, such as the Outer Space Treaty of 1967, primarily focus on preventing the militarization of space and promoting peaceful cooperation. While these are important principles, they do not adequately address the environmental impact of space activities. The lack of comprehensive international regulations leaves a dangerous loophole. Satellite operators are not held accountable for the environmental consequences of their actions. This lack of accountability creates a tragedy of the commons in space. Each actor is incentivized to prioritize their own interests, even if it harms the shared environment. To address this legal vacuum, we need a new international treaty specifically focused on the environmental sustainability of space activities. This treaty should establish clear guidelines for satellite design, launch practices, and end-of-life procedures. It should also include mechanisms for monitoring compliance and enforcing regulations. Furthermore, the treaty should promote international cooperation in developing and deploying technologies that minimize the environmental impact of satellites. While international regulations are crucial, the space industry also has a responsibility to address the issue of satellite air pollution. Leading companies in the sector are already taking steps to mitigate their environmental impact. One promising initiative is the development of design for demise guidelines. These guidelines encourage manufacturers to design satellites that burn up completely during atmospheric re-entry. This minimizes the amount of debris that reaches the ground or remains in orbit. Another area of innovation is the development of sustainable propulsion systems. Traditional chemical rockets release exhaust plumes that can contribute to air pollution. New technologies such as electric propulsion and solar sails offer cleaner alternatives. Furthermore, companies are exploring the use of biodegradable materials in satellite construction. These materials would break down harmlessly in the atmosphere, reducing the environmental impact of re-entry. We need a comprehensive regulatory framework that incentivizes sustainability across the entire space industry. The issue of satellite air pollution is not a distant threat. It is a clear and present danger. The longer we wait to address this problem, the more severe the consequences will be. We are on the cusp of a tipping point. The number of satellites in orbit is increasing at an exponential rate. Mega constellations are being deployed, adding thousands of satellites to the already crowded skies. Each launch and subsequent re-entry contribute to the growing problem of air pollution. The environmental consequences of inaction are dire. Increased air pollution will exacerbate respiratory problems, particularly in vulnerable populations. The ozone layer, already weakened from past CFC use, faces a new threat from satellite debris. Climate change, fueled in part by atmospheric pollutants, will continue to disrupt weather patterns, raise sea levels, and threaten ecosystems. We have a moral imperative to act. The time for action is now. From space, our planet appears as a fragile oasis, a swirling blue sphere enveloped by a thin atmosphere teeming with life. This iconic image, captured by Voyager 1, reminds us of our precious home. For millennia, humanity has looked to the stars with wonder. We dream of exploring the cosmos and pushing human ingenuity. But we must protect our planet as we venture further. Satellite pollution reminds us our actions have consequences. It highlights the need for sustainable practices. We have a responsibility to protect the space environment. Addressing satellite pollution ensures our quest for knowledge aligns with safeguarding our planet. Imagine a future where humanity has tackled satellite air pollution. The skies above are free from space debris. Our children can look up at the stars with wonder. International cooperation has led to robust space regulations. Satellite operators prioritize sustainability. New technologies like debris removal are widely used. This future is within our grasp. Thank you for watching Cosmic Chronicles, your journey through the universe. Don't forget to like, subscribe, and hit the bell icon for more cosmic adventures.